আমার পরবর্তীতে আসবে মাহবুবা আক্তারি।
Thanks a lot, Madam. She has introduced me already, and now I am here to represent something different. And let's have fun. Once, one of my friends told me she will name her daughters Alpha, Beta, Gamma. Guess why? Why? Because they are radioactive. If anyone try to disturb them, they will be. And that's why she told me that I want to name my daughters as Alpha, Beta, Gamma, so that no one can disturb them. From this, let's come to the point. It was a joke. Don't take it seriously. And we can guess that Alpha, Beta, Gamma is a radioactive substance or radioactive decay. And why we are so concerned about learning radioactivity? Can you guess? Why we are so concerned? Why we are discuss too much about this radioactivity? Why we should learn this? I am here to represent and clear this topic. Why we should learn this? Why it has a great importance in our life and in our many applications and many fields of research. And first, I would like to remember you. Do you know that Mary Curie? Can you guess this? What is this picture?
No. Yes. No.
Yes.
No.
Who can?
No.
Okay. Let me tell this. It's a Mary Curie's diary on which she wrote down her research work. And this diary was awarded her very prestigious Nobel Prize in Physics. And this is the diary. And we know that Mary Curie's diary or notes are still radioactive since she was working with radioactive substances, polonium and radium. The radioactive decay occurred. And these radioactive decay are captured by her diary. And this diary is in a museum now. And we know all things about radioactivity. My previous presenter has discussed this half-life of radioactive substances and how the radioactive decay occurs. And this concept is usually can be discussed in this case. And this is a paper which contain radium-226 radioactive atom, which it was captured, and a calculation was said that it will stay radioactive for next 1,000 years. And so from this we can guess that what was the effect of radioactive decay, and how much results it can be done. And you should know that I don't know if you know or not. Mary Curie was died of cancer, and she was affected by her own radioactive substances, radium and uranium. It was so harmful for our physical purpose, and it damages our DNA, tissues, etc. And for this, she was suffering a chronic cancer disease, and she died of cancer. Yes. And there are a lot of applications of radioactivity, and for these applications we have to learn first the half-life of radioactive elements. It's a very important topic to understand how a radioactive decay occurs and how much time it will take to totally be safe portion of radioactive decay radiation. And if we consider this, we can see in our picture that when we consider 100% of our concentration of radioactive substances, which will start decay at t is equal to 0 second, it will be reduced its half of its initial value. That means it will be 50% after its first half-life. When it will pass its half-past life, it will reduce to its half of its total initial concentration. And after that, in such a way, in similar manner, it will reduce to 1/4 of its initial concentration. That means it will be 25% of its initial concentration. Since initial concentration was, we have considered 100%. And after that, in similar manner, I am not going to tell this again and again. After a certain time, it will it will radiate less emission, and when time is increasing, it will emit less radiate, and it will be our safety margin. And after a long time period, it cannot harm us more effectively, more harm. It cannot be worse thing for us. Next slide, please. And this concept is very much important in understanding radioactive decay. All the things have its positive and negative sides, and we have already discussed some of its negative sides or harmful effects, and now we are discussing one of its very important sides, important research sector sides, which is radiocarbon dating. Can you hear this word, radiocarbon dating? No. Okay. We know there are many types of isotopes in our atmosphere, in our environment is available. So carbon isotopes, there are type of carbon isotopes, carbon 12, 13, 14. There may be many types of carbon isotopes in our environment, but in these types of isotopes, there are two isotopes which are radioactive, which are unstable in nature, which nucleus are unstable, and due to this unstable character we have discussed before, due to this unstable nature, it will radiate decay. And we are talking about carbon 14 isotope, and carbon 14 isotope is radiating continuous beta decay, and this concept is used in researching and determine the fossil's age. And how it is determined, I will try to make sure. We know living thing. Living thing means we are human. Some trees which are absorbing carbon dioxide from us, cows, and etc. All of those living things are interrelated. And when sunlight passes our atmosphere, it comes to our Earth. The Earth atmospheric nitrogen 14 atom will collide by neutrino particle of sunlight, and this collision will result in carbon 14 isotope production. This carbon 14 isotope, when we take breath, we don't take it, carbon 14 isotope, because we are human, we take oxygen, but when tree absorb carbon 14 isotopes with carbon dioxide, it will have a balanced ratio of carbon 14 isotope and carbon 12 isotope, that is natural isotope, which is carbohydrate. From carbohydrate, it is made of carbon and hydrogen. In carbohydrate, there are huge amount of carbon 12 atoms. Carbon 12 atom consists of carbon 12 nucleus, which is normal, not radioactive. But when trees comes to take our living, our product, carbon dioxide, it will absorb carbon 14 isotope also. That means trees have carbon 14 as well as carbon 12 isotopes. And this ratio can tell us age of this tree or any other living substances. But when a tree, in the living animals or living substances, there are a particular value of this ratio. But when it died, it stops taking carbon dioxide. Okay? A died tree cannot absorb anything. It will decay. And when it will die, it stops absorbing. But carbon dioxide will be converted to carbon 14 isotope, and this carbon 14 isotope is actually radioactive isotope, and for this radioactive isotope will decay beta radiation, and this beta radiation will be decreased. We have discussed half-life of radioactive substances. Say, as for example, 100% when tree died, we buried this, and after that we will get the maximum radiation, and after the first half-life we will get 50% radiation. That means radiation is decaying. And after that we will get 25%, and after that, and in similar manner it will be decreased regularly. And it will, and its ratio, consider the third case, 25% after its third half-life. The ratio of carbon-14 isotope and normal atmospheric carbon-12 isotope is not similar as the previous, which is in 100% concentration. It will obviously vary with the first. It will obviously different value. It will obviously show us a different value. And how much difference is occurred in this measurement? It will tell us the age of the fossil, age of the trees, how much ago it has died. And during this, it is the process which is carbon dating. Dating means they consist of two carbon. We normally use this word, dating. No? Yes. Okay. So dating means there will be two parts. So here dating is carbon with carbon dating, carbon 12 with carbon 14 dating. So we have a lot of fun. So next, some other interesting fact about radioactive decay. There are many applications in our physical field and many applications in medical sector. And we can see that radioisotopes are really formed because they are unstable in nature. But when we are able to find them, we are able to make them work out with our needed. Then we can get a large amount of facilities, large number of facilities. And some facilities are diagnostic application. We can use them diagnostic application and radiotherapy and sterilizing techniques which can be used in weapon developer industries and many other industries to check quality control, and research application which I have told in carbon dating section. And after that was first radioactive isotope which was used in radiotherapy. It was iodine 131 isotope, and it was used in 1946 for the treatment of thyroid cancer and hyperthyroidism. It was the first step when human used radioactive substance for our welfare. It was a great invention. It was great physical significance in our history of human science and history of development of science. Next slide, please. Radioisotopes are used as medicine. You know all about radiotherapy. We have heard a lot because nowadays cancer is a very available disease. We are looking cancer patients here and there, and we are actually used to know about this word, cancer and radiotherapy. And now we will discuss how much radioactive isotopes can be used in different types of diseases like cancer and any other disorder or genetic treatment. Cobalt-16 isotope commonly used in external beam radiotherapy, and it is useful in sterilizing technique. And erbium-169, which can be used in arthritis pain of synovial joint, and holmium-166 isotope, which is actually radioactive, and it can be used in developed for diagnosis and treatment of liver tumors. Liver tumor can be liver tumor has DNA cell, and we know that radioactive decay can destroy DNA, and tumor cell can be destroyed by this decay. And we are using this in our human welfare. And then iodine, the last one is iodine-125 radioisotope, and it is used in cancer therapy. Different kind of cancer are available. We know University of Cambridge has listed a cancer list, and due to radiation, it may larger harmful to us. And we know, and it can be useful in hormone treatment. Sometimes imbalanced hormone can make us suffer. So it can be used in hormone treatment and refiltration of kidney. Sometimes kidney failure is occurred. So patient have a lot of pain they have to face. But this radioactive isotope can be used in this to solve this problem. Next slide, please. We can see that a cancer patient is taking radiotherapy. And here is chamber. This is radiotherapy chamber. This can produce radiotherapy, and she is taking cancer treatment as radiotherapy. Next slide. Can you guess what is this? I think you can guess. Some of you have told paramagnetic bomb. So it is an atomic bomb bombardment on Hiroshima and Nagasaki, which was most black chapter of our human history. Due to this bombardment, 70% of the buildings was burned out due to this bombardment. And in 1945, when the atomic bomb, which was made of uranium and which was a large amount of collection of TNT, trinitrotoluene. It's a burnable, it's a harmful substances to all. And when it was fallen down towards Hiroshima and Nagasaki, it was about 70% of the buildings and human constructions are destroyed by this bombardment. And estimated amount of deaths are recorded as 140,000 very dangerous disease was then affected people, and they are suffered many types of chronic cancers and inherent DNA disorder. And we can see in picture there are some physical problem due to this radiation. And still now, people are suffering a lot due to this radioactive decay. And they are having many physical problems. They are having bad reproductive system. They are facing some DNA disorders, and they cannot live normal life for this radiation. And after that, I would like to review our total presentation. And for that, our first presenter, I will not mention your name because it has mentioned already many times. We have discussed first radioactivity, what is radioactivity, and its types, its causes, why a element radioactive, show its radioactive behavior, and there are three types of radioactive decay, and there are alpha, beta, and gamma decays, and we have learned about alpha, beta, and gamma decays, how it was occurring from an unstable nucleus to a stable nucleus, to form a stable nucleus. And we have informed about the mechanism and applications of these radioactive decays. And after that, we can conclude that from this our lecture, why we have learned this. We have learned this to be a good human. A worse mind, a devil mind can destroy all the peace of the world. We have seen that in Hiroshima and Nagasaki. One mistake can destroy thousands of people's life, can destroy thousands of years to recover it. And when a power is governed leaded by a worse mind, a devil mind, it will destroy all pieces to our earth. But our beautiful mind can change this world to a better place. And I believe that